Now that we're all experts on figuring out what makes a perfect square trinomial and how to use them and recognize them, we're going to use perfect square trinomials to complete a process called completing the square to solve quadratic equations. It's easier than you think it is, but you have to know some basics. So let's go back and look at some of our previous work. Right here I have a trinomial in process. I would like this to be a perfect square trinomial. I can already see that I have a perfect square here with x squared, and I know I'm going to need a perfect square here to make this a perfect square trinomial. But the question is, what perfect square am I going to want to have? Now, based on the work that we just did, you should remember that I'm going to be able to easily find this term by simply doing a couple of very, very basic things. First, I need to look right here at this 8x squared, or this 8x rather. I know that this happened as the middle term from FOIL when I multiplied two different things. I must have multiplied x times something twice to get 8x. And I know that that must have been a 4 and a 4, because 4x plus 4x is 8x. So the last term from FOIL, when I used it, 4 times 4 should have been a 16. That's the number I'm looking for. But there's got to be a little more efficient way. And there is. What we really do is we focus on the middle term, 8x. We ask ourselves, what is 1/2 of that middle term? And most of us realize, oh, that's 4 times x. Well, I know where the x came from. The x came from the first one. The 4 came from the second term. I simply square it to get my last term. So again, all I really have to do is focus on this middle term, take half of it, and square it to get my last term. So once again, I'm going to look at this. This is going to become a perfect square trinomial. We're going to do it the fast way. I'm going to focus right here on this number, -16. The fast way of creating a perfect square trinomial is, once I know that I have a perfect square out here, I focus on this middle number, and I'm simply going to take 1/2 of it. 1/2 of -16 is -8. From there, I'm going to square -8. That's going to give me whatever number should be here to form a perfect square trinomial. But the best part about this strategy is it tells me exactly how I would factor this. This would factor as x from the first term and -8 from the last one, and I saw that that -8 right here matched the -8 right here. So I went from not knowing anything about the problem to knowing everything about it very, very quickly. Let's look at it again. Uh-oh, I have a number that's not fun to get half of. So, oh well, I'll do it anyway. Again, I know I have a perfect square here, so I'm going to focus on this number right here. And once again, I'm going to ask myself, what is 1/2 of that middle number? 1/2 of 7 is 7/2. I am not going to write it as a decimal. I am not going to write it as a mixed number. I'm going to keep it as an improper fraction. Now I know to get the number I'm looking for, I have to square 7/2. Well, 7 squared is 49. 2 squared is 4. So to complete this square, to make a perfect square trinomial, I needed 49/4 there. It looks nasty, but remember, we know how to factor this because we know there's an x in the first place, and just like with the last problem, whatever I have here is what's going to come here. So I'm going to have plus 7/2 squared. If you FOILed this out, you would get x squared plus 7x plus 49/4. So now you're asking yourself, who cares? Why do we need this? Well, let me look at this problem. We already have a strategy for solving problems like this. I remember from the last thing we did before winter break, all I'd really have to do is subtract 20 from both sides, setting it equal to 0, giving me x squared plus 14x minus 20 equals 0. Now all I have to do is find two numbers that would multiply to -20 and add to +14. And that, well, let me see. 1 in 20? No. 2 in 10? No. 4 in 5? No. I've exhausted all of my possibilities. None of the things that I know should work do work. This problem is one of those problems that they give us in math that does not have a nice, happy, easy solution. But we can still do it because we're brilliant. Here's that same problem. I'm going to focus only on this side of the equation. And I can see it is almost a perfect square trinomial. In fact, the only thing that it would need to have to be a perfect square trinomial is half of 14, which is 7, squared, or 49. So, if I were to do this problem, I would be able to say, golly, I'm going to take 49 and add it to both sides of this equation. And remember, to keep it equal, we have to add it to both sides of the equation. So now I have x squared plus 14x plus 49 equals 20 plus 49. I will immediately factor this as x plus 7, quantity squared, and I'll combine like terms on the other side. Now we have strategies for solving this problem. This is what we've been doing for the last couple of days. We know that we can take the square root of both sides, and I'll end up with x plus 7 equals the positive and negative square root of 69. And I'll simplify that if I can. 3 will go into that 23 times. Since 3 and 23 are both prime numbers, I can't simplify that root. I'll finish this by subtracting 7 from both sides. My final answer is going to be simply x equals negative 7 plus and minus the root of 69. That's it. Let's go to the next problem. Here we have another one like it. Now again, I could subtract 12 from both sides, but then I'd have to find two numbers that would multiply to negative 12 and add to positive 6. 1 and 12 won't do it, 2 and 6 won't do it, 3 and 4 won't do it. So I can already tell in my mind that that strategy isn't going to work. Instead, I'll focus on this 6, and I realize that this is almost a perfect square trinomial. All it would need is half of 6, which is 3, squared, which is 9, added to it in order for it to be a perfect square trinomial. So that's what I'm going to do. I'm going to call this x squared plus 6x plus 9, and on the other side I have to add that same 9 to keep it equal. Well, the reason I made it plus 9 was so I could now factor it as x plus 3 quantity squared, and on this side I'll have 21. Again, we've got strategies for doing this. We can take the square root of both sides. That will give me x plus 3 equals positive and negative square root 21. 21 is 3 times 7. Those are both prime numbers, so this root can't be simplified. I'll then subtract my 3 from both sides, and I'm left with x equaling negative 3 plus and minus the square root of 21. And it's just that simple. Last thing I wanted to look at is right here. X squared plus 20x equals negative 50. Now, sometimes students get confused because we know that we can't have a negative square root and have real solutions. So I wanted to point out that just because I have a negative 50 over here does not mean that this problem has no real solutions. Instead, what it means is I still focus on this side. It is almost a perfect squared trinomial. I will take half of 20, which is 10, square it, which is 100, and add it to both sides. So I will do that right here. X squared plus 20x plus 100, and that's going to equal 50. Negative 50, if I forgot that negative, I'd be very sad. Plus 100. And now I can factor this side here and call that x plus 10 quantity squared, and it's going to equal negative 50 plus 100, which is 50. Now I'll take the square root of both sides, and I'll end up with x plus 10 equals positive and negative square root 50, but 50 is just 25 times 2, and 25 has a square root of 5. So I'm really going to write this as positive and negative 5 square root 2. Remember, when we can simplify our radicals, we do simplify our radicals. So if I have x plus 10 is equaling positive and negative 5 square roots 2, I can subtract 10 from both sides. I'll end up with x equals negative 10 plus and minus 5 square root 2. Now here's the point. We have gone from problems that we could not solve with the techniques we had learned before winter break to being able to solve them by completing the square now. Watch this video as often as you need to understand these techniques.